All right, so drew my graph. Q is at -1 up 3. And we're looking for the midpoint, oh, sorry, the Q is the midpoint of line segment PR. And P has coordinates of 5, 6. So over 5, which would be about there, and 6 would be about here. And P has this, so it says P is the coordinates here. So we're looking for R. And since Q is the midpoint, right? Our midpoint is there. It's going to be somewhere over here. And this is not the best graph. Okay, that's not the point. The point is not to be, something good enough to solve the problem with. In this case, it's just there to give us an idea, right? So we're going to still use our midpoint formula. So we know one of them. So we're going to have to use that midpoint formula. And this one's kind of a weird one because it is similar to the one that we worked with before. But I'm going to leave a lot of space in there. So, right, there's going to be a big old space here. And the thing is, we do know the midpoint. So typically, this is what you would use if you were just looking for the midpoint. But in this case, it's kind of the opposite. We know the midpoint, and we're trying to find the other sides, right? So we're trying to find R. So let's see, trying to find R. Well, we know that this is the midpoint here. So we can plug these points over here. So that's what I'm going to do. I'm going to go ahead and take my X value. So I know that this should come out to -1 on the X side, and it should come out to 3 on the Y side. Now, to get the this one here, I'm going to have to find out what the opposite end is. So in this case, we have P, which is over here. And I'm going to have to just substitute it with one of these, just one of these. So 5, and again, make sure your X and Y goes to the right place. A lot of these formulas, you can kind of, you can change a few things and it will still give you the answer, okay? But you at the very least, you have to make sure that you have the X and the Y's in the right place. All right, so now I have to solve each of these sides, right? So I got to find out what is the X and what is the Y. Once I get this X and that Y, that will tell me what the X and Y coordinate is for this number here, for this R point that we're looking for. So to do this, I'm only working with this one right here for now. Well, I got to get rid of this 2, because if you remember the order of operations for algebra, one of the first things we have to do is get rid of parentheses, which, well, there kind of is a parenthesis, right? Because these two are grouped together. Because when I have this divided by 2 symbol here, it means both of these are divided by 2, which means they're grouped together. So if you see a fraction bar in any kind of algebra problem, that kind of means that you're gonna have to work with that parenthesis first. So anyway, what I'm gonna have to do to get rid of this 2 is I'm gonna have to double both sides, right? Because anytime you're stuck on a problem and you're like, well, what do I do next? Well, think about it. What is this 2 doing to the X? Well, it's dividing it, right? I said that before, but it's dividing it. So we're gonna have to do the opposite of divide it by 2, and that is to multiply it by 2. So I'm gonna double this side and double this side. But when I double this side, what happens is the fraction goes away. There's no more fraction, gone. So now that there's no more fraction, I can just solve this like an ordinary algebra problem. So again, I got to get these numbers away from the X. And that means get it away from the X, which means do the opposite, right? So if I have +5, I got a -5. And when I -5 to both sides, that should give me my number. Now, X is usually supposed to go first, and I like to have it go first. So what I'm going to do is I'm just going to flip it so that it's just on opposite sides. So both numbers and variables switch sides. And that's what we call reflexive property. It just means that you can reverse something. Like, okay, some things don't make really a lot of sense when you say them, but like it would be something like, your sweater is blue, or blue is the sweater. Okay, they both kind of mean the same thing, even though one sounds better than the other. You know, I am 12 years old, or however old you are. Wait, no, you'd be like 15-ish, 16-ish maybe. You know, I am 16, or 16 is my age, whatever. Just different order. All right, let's do this side now. Same thing, I'm gonna double both sides, which normally if I could, I usually mark it so that you can see what I'm doing. So I doubled both sides so that this side becomes 6. So right, double 3, that becomes 6, and y plus 6 is what we have on this side. And I'm gonna have to get rid of that 6 also. So, well, in this case, it's gonna cancel out. So 0 equals y, because 6 minus 6 is gonna be 0. But I'm gonna reverse it again so that I say y equals 0, right? Because it's just easier to say something like, you know, again, well, this is not a really good example. Or like you could say, I owe $7, right? That's the way you would read it, but you don't say $7 I owe. Even then that makes sense. This way makes more sense, just looks better. Same with this one here. So we could say that, you know, I don't know, if a person is 0 years old, or we don't say 0 is the age, we say the age is 0, you know, maybe like for a baby or something. Okay, but at least we know the x and the y coordinates. So now we know that r, this other endpoint here is 7, 0. And I kind of didn't want to put it on the line, all right? This line's not really straight. Like I said, this is not, it's not supposed to be something that we're, you know, use to solve the problem. It's there just to give us an idea. So if you go back 7 and stay on the line, that makes sense. That does make sense. Okay, it's not so bad that you have to, you know, rewrite this whole thing. And a lot of times diagrams are like that. Okay, so diagrams are not there to give you the answer. They are there to kind of give you an idea of what you're looking for. And that helps out, knowing what you're looking for. All right, so let's go ahead and move to another one here. Now this one looks like it's just using algebraic expressions. It's not using the coordinate plane, so maybe we don't need to draw one, but we could draw one, just a simple one. We don't know what direction it's going in or anything like that, but that's fine. So we know that there's P, which is a midpoint of X, Y. So we have X and Y. So from the segment XP, we have 8X, put it up here, 8X minus 2, and PY is 12X minus 30. Oh. Do you have a question? That's fine if you have a question. But if not, that's fine also. Let's go ahead and read the question. So find the value of X. Okay, so this one's a pretty simple one. Well, using segment addition postulate, or the angle bisector, the bisector, remember, that means it cuts it directly in half. So if this is the midpoint, it means it's right in half of both of those. And if it's right in the middle, that means both of these are going to be equal. Oops, almost forgot the X there. There you go. So now we're going to use our power of algebra. And one of the first things you do, besides parentheses and like terms, or groupings and like terms, well, we got to pick a side for the variable to go on. And I like to keep my variable positive whenever I can. I like to keep the variable positive. And part of that is just, if you remember yesterday, I think I did an example of it yesterday, where whenever you have something that's negative, it just looks off, and you know, you can sometimes confuse yourself and get the wrong answer. But in this case here, I'm going to go ahead and just keep it positive. So just add 30 to both sides, -2 plus 30. -2 plus 30, it's going to be 28 equals 4x. Divide both sides by 4. And then we have, oh, I'm going to reverse it, so that way I put the answer up here. So X goes first, and then whatever's on this side, I'm gonna put on that side. So 28 divided by 4 would be 7. There we go. All right, so we got one more to go, and then we can go on to the next lesson. All right, so make sure you get this one copied down. I'll give you a couple more seconds, and then we'll move on to the next one. All right, let's see. Using the diagram to the left, if line N, right, so this is our line N, bisects QR, find QP. Oh, QP. Oh, there's QP. We're done. Hey. Nope, not that easy, right? So again, bisecting means that it's directly cut in half, exactly in half. So that means these two things are the same size. Again, pick a side for your X to go on. I'm gonna put it on the left side here, just so it stays positive. And in most cases, with most problems, that's probably one of the easier things to do. Again, it just prevents you from having to work with a negative. All right, so here we have 24. Put those together, 4 plus 19, 2x. And again, I'm gonna reverse it so that x goes first. I'm just switching the sides, so I'm still dividing both sides by 2, but really I'm just asking myself, what times 2 can give me 24? Well, that's easy, 12. X equals 12. All right, but that's not what we're looking for. Remember, we want to look for the length QP. So QP is 3x plus 5. So I'm going to take 3x plus 5, and I'm going to substitute in 12. So 3 times 12 is 36 plus 5. And that would give us 41. Oh, and let's write it the way we're supposed to. So QP equals 41. And I could put the little line segment on there. That's probably the best thing to do. Now, if you want to check it, what you could do is, since we know that both of these are the same size, right? Both of these segments on both sides of N should be the same size. So we're done with this problem. I'm going to check it though. Just going to check it. And I'm going to do that by plugging this in, so into the other side, right? So I get 60 minus 19. Use my calculator just to check that. 60 minus 19, it's going to be 41 also. So both sides are 41, which means it's directly bisected. And if it's directly bisected, that means that it is, well, it is what we're looking for. All right, and that's it for that one. So we finished the one we started yesterday. And I'll give you a second or two to copy that one again, and then we'll switch over to the, well, what we're supposed to be doing today. And again, until I know exactly where everybody is for this first week, we're just gonna go through this entire first packet. Also a reminder, if you know what you are missing, okay, so if you were in Mr. Moreau's class, right, if you were in Mr. Moreau's class, which I'm guessing most of you were, if you have any work from him, you can turn it into me and you'll still get something, okay? So again, I'm still trying to get, I'm trying to get your scores from last spring. If I can get your scores from last spring, you're just going to be kind of continuing where you left off in a way. But I need to know what you're missing, what you have, what you need. All right, so this is the one we just did now. This is the homework here. Maybe we'll cover that. But if I had some more time, I'd go ahead and go over that as well. But usually I like to put the homework, I'd like to put the homework, if I have time, I like to put it up. And there are two types of assignments. There's the in-class work, and that is the one you do in class. And then you also have the homework, which is the part you try on your own. And they're both worth points, so you need to turn in both things. Every packet has a rubric attached to it. So it's usually the second or, early on somewhere. So if you open your packet, you'll get something that kind of looks like this. Okay, yeah, I know sometimes you might not see it that well. But that rubric tells you, and again, it's just like, it's usually like the second or third page in the packet, but it tells you how it's graded, how your assignments are graded, how many points you need, stuff like that. All right, so hopefully you are copying this down because we're going to move into the next part, and that would be angles. Oh, really quickly, there's quizzes too. All right, so there's these things that are marked quizzes. For now, they're all just going to be, what do you call that thing? Extra points, right? So it's all just going to be extra credit. No, they're not really needed. So if you don't do them, it's not going to cost you anything. But I thought I'd just include them anyway because we're kind of going through the course pretty quickly, being summer and all. So if you see anything that's quiz, don't worry about it. We're only looking for, again, the in-class work, which is like what we're doing now, and the homework parts. And the homework ones are marked homework on top. So on the top of the page, it'll say homework, or it'll say something like Unit 1, which is what we're on now. Unit 1, Homework 3. Well, I'm just going to zoom down really quick and see where we're at. So the one we covered was Homework 3. This one would be Homework 4. So it's going to say something like that. So you'll know it's the homework. It always says it. All right, let's get through this. An angle is formed by two rays with a common endpoint. So again, here's ray, so we could say that this is ray BA and then BC. Common endpoint is called the vertex. So in this case, B is the vertex of this angle. Rays are called the sides, right? So if you imagine like any kind of shape, it's got to have sides on it. So here we got side 1, side 2. Name an angle using 3 letters, and the middle letter must represent the vertex. So there's 2 ways you could name this angle. We could name it angle ABC, which is probably what most people would call it, but you could also call it CBA. All right. And sometimes with angles, you might not always be able to put them in alphabetical order. But again, both ways are right, but we generally like to have things in alphabetical order whenever we can. Right. It's just better that way. It just looks better, feels better, sounds better. So there you go. Middle numbers, they're the vertex. Use a single letter if there is one angle located at the vertex. So in other words, we could call this angle B, all right? But what it means by if there's only one angle, let me see if I can just zoom down here really quick. Like for instance, something like this, right? We can't call this angle B because there's 2 angles. And on some of these shapes, you might have multiple angles. Like this one has 4 angles. This one has 1, 2, 3, 4, 5. So you can't call it angle B because, which of those 5 are you talking about? So that's why we have to use one letter. And when we're using the measure of an angle, we use lowercase m. So in this case, we're saying the measure of angle ABC is 60 degrees. Right? And we can see it right there on the diagram. And these are parts that you're going to have to fill in as well. So types of angles. So you have acute angles. And remember, just the word, I think, actually, that's a pretty good question. I'm sure one of the first things I'm going to get is angle. But let's see what the word acute is. Let's see, bad, difficult, or unwelcome. I don't think that one really works. Here it says angle less than 90 degree, high, shrill, having someone perceptive and shrewd. That's weird. All of these kind of seem like bad things. Can describe a severe condition. That doesn't make sense. I don't know. The reason I thought I was going to look that up was because sometimes on like TV shows, or you'll be watching a YouTube video and it'll say something like, "Oh, the guy suffered an acute heart attack." So does that mean it's small, like a small heart attack, or does it mean it's like really bad? Because it says severe and shrewd and everything. I don't know. Well, let's just go with what your junior high teacher said, and just remember that acute means small. Like when something is small, it's cute. And obtuse is the opposite of acute. It's when something is greater than 90 degrees. So here we have a very wide angle. Right is equal to 90 degrees, and straight is equal to 180 degrees. So with a straight angle, if you remember back in like kindergarten to maybe third grade, if you had those metal scissors, you could open them all the way up so that the blades would line up. And when the blades lined up, you would just have a straight line through them, through the tops. So that's kind of what a straight angle is. You might be looking at that thinking, oh, that's a midpoint of a line. But if it tells you it's an angle, then it's a straight angle. It's a 180 degree angle. All right, so let's see what we got here. Name the vertex of the angle. So, right, vertex is the middle one. Or vertex can also mean where an angle turns. So here, if we're coming from this side, once we hit K, we have to change direction. Or if we're coming back the other direction, we move to the left and then we hit K and then we go down. But either way, K is the vertex of the angle. Name the sides of the angle. So KJ and KL. So those are the two sides. Think of it like clock hands, right? So if this was a clock hand, it might be something like 8:15 or something like that. Probably not exactly, but yeah, 8:15 would be a very close time that this clock would show. But basically, in this case, it would be like the hands of the clock. All right, let's move on to the next one. 3 ways to name the angle, right? So there's 3 ways. You can name it with one letter and the vertex. But that only works because we only have one angle here, right? We only have one. This is the only one we have here. Here we have JKL. So coming from this side, JKL. Over here we have, well, starting with LKJ. Classify the angle as obtuse because it's got a really big angle greater than 90 degrees. And I usually tell students, if you're not sure, there's 90 degree items everywhere. In this case here, I have this notepad, and you could just line that notepad up to an angle to see. And if it's close enough, excuse me, a lot of times that's just good enough, right? Because, well, even, yeah, if it's close enough, then you can just call it a right angle. But if it's definitely bigger, then, it's obtuse. If it's definitely smaller, then it's acute. All right, so here we have another example. They want us to name the vertex, so let's look at the middle number. I'm sorry, the middle letter. So RST. So S is the turning point. So that's our vertex. Name the sides of the angle. So SR. So coming in from this side, we have S to R. Over here, we have S to T. And give 3 ways to name the angle. Same thing, we can name it by the vertex. So S is our vertex. We can name it either going from left to right or right to left or up to down, down to up, whatever. Actually, that doesn't really work out in this case. So RST and angle TSR. So again, remember that little symbol there means angle, although it should be a little bit lower though. It kind of looks like one of those less than or greater than signs. But usually it's a little bit, one of the sides of that angle is usually a bit lower. And classify the angle. Another way you can tell if something is a right angle is because they'll usually put a little box, little square there, and that square tells you that it's a right angle. All right, and again, most of these are pretty easy. I think we covered these on the first day, right? We're just sort of showing them in practice, showing them being used. Congruent angles, so measure of angle A is the same as the measure of angle B. Then those angles are congruent. So in this case here, looking at the diagram, angle A is 75 degrees. Angle B is also 75 degrees. Now these are two different angles. So sometimes we'll say they're congruent, and that's what this symbol means here. So they're congruent, right? They're two different things. They're just the same size. So it's just like, again, if you know somebody who's the same height or same age as you are, you know, their height is congruent to yours or their age is congruent to yours, but you're not equal because you're not the same people, right? You're not the exact same person. So that's why sometimes we say congruent and not equal. All right, so there you go. And again, this is just filling it in, just filling in what we're going through. All right, I'm gonna leave that up just in case anyone's still writing it down. All right, angle bisector. So again, bisector is kind of like what we talked about before. And I think some of you guys are new. I think maybe one of you have already seen this before. But one story I usually tell about this one here is quite a long time ago, right? My cousin and I were eating pizza with all our family members there. And there was one pizza slice left. Both of us wanted it. And we had to cut it fairly. So there was an idea that one of our family members had, and that was one person will cut it and the other will choose which side they get to pick, right? So in this case here, maybe we're both really hungry when we both really want that bigger slice of the pizza. So if the first person cuts it so that one side is smaller, so here I cut it in a non-equal manner. Well, the second person who chooses can simply choose to take the larger one, and now you're stuck with the little piece. So what this does is that it forces the first person to really cut it as equally as they can, because that's the only way you won't lose is if you can cut it directly in the middle, then neither option will be better than the other. So let's take that pizza and we're gonna go ahead and cut that in half as much as we can. Now I have two very equal slices. And now the first person who has cut it has made it so that the second person doesn't really have a good way to choose, right? Because they could choose either one and they're not gonna get a whole lot more. You know, they might get maybe a few crumbs more, but really it's not that beneficial. So that's kind of what an angle bisector is. So again, you can imagine this is a pizza and this ray from B to D is the one that cuts these directly in half. So a ray that divides an angle into two congruent angles, right? So both of these are congruent, which means they're the same size. So in this diagram, right, BD is the angle bisector, and that's what I said, it cuts it directly in half. And don't forget bisector, you know, if you're ever confused with something in math, just break the word down into the words that make it up. So in English, we always have words that are a combination of other words. So like bi means two. As I always say, a bicycle has two tires and a binocular has two glasses. right? And there's probably a lot of other words you can think of that start with that. And again, sector is just like a section or a piece. So cuts it in two pieces. So therefore, angle ABD, so that's ABD, so just follow it along, is congruent, and that's what that squiggly line means. It means congruent, DBC. So now again, we have to name these angles. We can't just name it B because there's two angle Bs. We have to name it by all, by the side, the vertex side. So that's going to be at least 3 points. All right, so let's go and move on to the next one. And that's going to be perpendicular and perpendicular lines and perpendicular bisector. So two lines that intersect at a right angle. So that's what perpendicular means. And again, if you were to grab an item, like a piece of paper, and fit it up against that angle, then that would be a great way to tell if something is, it would be a great way to tell if something is perpendicular. But in this case, in this diagram, I can see there's a little square there. That little square means that it is indeed a 90-degree angle or a right angle. And we use that symbol here, which kind of looks like an upside down T, but you can also think of it like here's the ground and then there's a flagpole, right? If you're gonna have a flagpole, you don't want it to be kind of sideways, right? If you want a flagpole, best way to do that is just straight up and down, perpendicular with the ground, all right? Best way to make a flagpole. So in the diagram to the right, we have line L perpendicular to line M, and that's what it says. That's how you would write it. L is perpendicular to M, and here we can see that we have one that's completely vertical and one that's horizontal, and they cross right at a 90-degree angle. All right. Next one here, perpendicular bisector. So here we have a line, a segment, or ray perpendicular to a segment at its midpoint. So perpendicular bisector, again, is kind of like cutting something directly in half. Now, I'm running out of string because I do this almost every time I do this. But if you have a segment here, right? So the line segment has endpoints, so it doesn't go on forever. Just like our line PQ here does not go on forever. And if I were to fold this string in half, so just take it and join the ends together and kind of fold it, you can see that I'm holding the midpoint here. And I could mark it there, and that would, that way you'd know exactly where the midpoint is. So that's kind of what's going on right here between P and Q, and that bisector would be, crossing it directly at its halfway point. So that would be its midpoint. And again, LM is the perpendicular bisector. That's the one doing the cutting or the crossing, whatever you want to call it, to PQ. So, and these marks here indicate that it is the same on both sides. So it's just, they're both congruent. Sometimes they might use 2 marks or 3 marks, especially if they're trying to have like multiple angles and multiple side segments that are the same. They're trying to show you that they're all the same. So let's see, where are we at now? So we go until 8:50. So it looks like I got about 10 more minutes left. This one's kind of a long chapter, so we might end up having to go over it again. I mean, we might have to split this one into 2 parts here. So let's see, what can we do? Let's try to finish this page here. Let's try to finish this page here. And maybe this next one here. And then we'll go ahead and call it a day. We'll take our break because we have what I call the large break until 8:50 to 9:45. All right, so write another name for angle CBF. So CBF. Well, we could just call it FBC, which is what they did right here. They just called it FBC. So again, you can go backwards. And in this case here, there's no way you can make it alphabetical order. So both of them would be equally right? Because, well, CBF, right? C, does not come before B, so you can't do that. And if you had CBF, well, this is not in alphabetical order either. So there's no way you could make it in any way alphabetical order. So both names would be equally right. But if you can do alphabetical order, it just looks better that way. Again, looks better, sounds better, probably smells better. All right, next one here. Name the sides of EBD. So EBD. So this one's actually got 2 angles in it. And if we name the sides, we have EB, which is here, and then BD. And again, we mark it with a ray, so it only has 1 arrowhead because it starts from B and then continues on forever in this direction, and then again in that direction. All right, and when writing a ray, you have to write it in the right way. So you can't say like B, E, and then have the arrow point to the right. All right, the arrow always has to point to the right. And it always has to, it always has to go from the origin of the ray, you know, where it begins and then keeps going. All right, so classify the angle ABC. So A up here, B, C. So that's a straight angle. So give an example of an obtuse angle. Give an example of an obtuse angle. So obtuse, remember, we want to make sure that well, there's actually a lot of them we could pick. So in this case, I think that one would be, it could vary on that one, but here they chose EBC. That one would probably be the best choice just because there's nothing between it. You know, it's not a combination of other angles. You could probably also pick something like EAD, so that'd be EBD. So EBD would also be another one too. All right, so name 2 congruent angles. So looking at this diagram, we're looking for 2 angles that are the same. Now in this case, it's gonna be kind of easy because you can tell right here, right? They'll mark these angles so that you can tell they are the same size. Mark here, mark there with those arcs. I think that's the right word. I mean, they are arcs. I don't know if there's a better word for it. Like I say, I don't normally teach geometry. I haven't taught geometry since like 2016, 2015. Yeah, it was a long time ago. So a little bit of this I just had to brush up on. Anyway, let's see. We also know that they're congruent because of if they're opposite angles, right? If they're on the opposite side of each other with 2 straight lines, that means that they are going to be congruent. All right, let's move on to the next one. Name a perpendicular bisector for BD. Oh, sorry, name a perpendicular bisector. Oh, okay, so, well, if we have AC, BD is a ray that cuts it directly in half, so that would probably be what we're looking for. And we can tell because, again, these marks tell us that this segment here, AB, is the same as BC. So look for those marks, and that should be able to tell us what we're looking for. Okay, this one has a lot of the things that we have to classify. All right, so in this case here, sometimes you can name them. You can name the angles with numbers instead. So they want us to find the vertex of angle number 2. So here we have angle number 2, and the vertex would be T. So T is that one right there. Name the sides of angle 4. So here we have 4, and starting with T, that's our vertex. We can go TW, which is this one right here, and they labeled it right there. And then TZ. So TZ is this angle over on this side. And those are just the sides. Those are the parts that make up the angle, the lines or rays that make up the angle. All right, write another name for angle 3. So angle 3 is this one down here. And it looks like they went with ZTU, but you could also go with UTZ. All right, again, both of them work out. And I don't think that you could do anything better to make it in alphabetical order. And that's usually the case. You know, they don't usually try to make things in alphabetical order. It just sort of comes out that way. All right, so angle 1. So here we have angle 1. So YTX. So angle 1. And again, you could also name it as XTY. That would be right. Okay, looks like here we have a lot of classifying what kind of angles we're looking at. So YTW. So YTW. Well, you can see the box right in there. On the inside angle of that, you can see that there is that box, which means it's a right angle. Classify YTU. YTU. Excuse me. So that's this angle here, and you can tell it's really big, so it's bigger than 90 degrees. I would think that 1 would also be a perpendicular. And you can see that it's obviously when you combine them both, it's definitely bigger than 90 degrees. So that would be obtuse. XTU, which is this one right here, pointing at it. And that one's obviously acute. It's definitely smaller. And since this is a bisector, I could probably say that this would be a 45-degree angle. Just because I think angles 1, 5, and 4 would be 90 degrees, and 2 and 3 together would be 90 degrees. And that's what a lot of geometry is just sort of jumping from what you know to finding out other things that you may not know right away. All right, next one, WTX. So WTX, and that would be a straight angle. And if it's a straight angle, then that means that, yeah, these are all 1, 5, and 4 are all 90 degrees. Name 2 perpendicular lines. That's a pretty easy one, WX, right? So we have WX, and that would be perpendicular to YZ. Name a angle bisector, so TU. So TU here. Because again, 2 and 3 are the same size. So if we had these 2 angles together, you know, we might have another angle, but it's been taken in half. And like I said, this is probably 45 because 45 is half of 90. Each of those would be 45 degrees. All right, so it looks like we finished right on time, actually. So we're gonna go ahead and go into the next part, which is called independent student learning. And then we'll be back at 9:45. So that's almost an entire hour. Now, again, you should be on Zoom this whole time, I guess is the kind of the way they want it. If you have any questions about the homework, if you have any, you know, help or any questions, you know, that's the time you should be asking those questions. So again, we have a whole almost 55 minutes of, you know, that's the time that you have to work with stuff and all that stuff, okay? Now, I'm gonna go ahead and end the lesson now.